All right. Hello, everyone. Can you hear me? Good. Okay, let's see what we are supposed to do today. I have a couple of points to go through. Yes, the first one is midterm. Let me share the screen. Midterm exam. All right. Midterm exam this is the announcement. Please write down the date and time, which is 2 weeks from now. 2 weeks from now, which is Monday, November 2nd. Let me double check the date one more time. Yeah. Monday, November 2nd, from 2:30 to 4:30, exactly the time that we have lecture. On Monday, not next week, the week after, when we have our lecture, I'm going to set up the midterm exam for that time. It's a 2-hour exam starting from 2:30 to 4:30. As I said, it's the same time slot that we have for lecture. That would be the time and date. In terms of subject covered, as I said here, it's end of chapter 4 in your textbook, which means starting from chapter 1 to end of trust analysis, which is chapter 4. Then what we have, if you look at what we covered in chapter 2, was the fundamental of SolidWorks simulation. Then we look at solid element and what is the solid element and what is a mesh refinement in order to reach to convergence test, and what was the concept of convergence test. Then we look at the different types of meshing techniques in SolidWorks. That was a standard mesh with a mesh refinement, which is that's a standard approach. Then we look at the standard mesh with automatic transition. Then we look at the curve-based mesh. Also, we look at edge adaptive and p-adaptive. Those are the topic that we covered in terms of mesh refinement in chapter 3. Also, we talked about global mesh refinement and local mesh control, and we covered that one as well. Also in chapter 3, we talked about one key issue, which was a stress singularity, and the concept of a stress singularity, and we went through a couple of examples to demonstrate what's going to happen if you have a stress singularity and what is the source of problem. That what we covered chapter 3. And chapter 4, we started with one-dimensional beam element, and we said there are 2 approaches. If you remember, we said one approach is to use traditional solid modeling techniques and create extrude, revolve, and so on. But you need to create, if you have more than one segment, you need to create multi-body environment, meaning that when you apply revolve or when you apply extrude, make sure that you are going to uncheck merge result. And then when you are moving to SolidWorks simulation environment, what you are going to do, you are going to just treat the solid as beam element. That was approach 1. Approach 2, we said in SolidWorks simulation, you are going to start from weldment, and you are going to bring the weldment to SolidWorks environment, and you are going to make the part with weldment. If you do that, then when you go to SolidWorks environment, again, you have multi-body environment, but this time you do not have to convert or treat them as a beam. Automatically, SolidWorks simulation is going to consider Weldment as a beam element by default. And we said that is one directional beam element, and then we talked about direct stiffness method. In direct stiffness method, we said we are going to look at the mathematics behind the SolidWorks simulation, and based on the displacement method, which is direct stiffness method. And we said in order to do that, you need to develop the beam element first. And if you remember, we developed the matrix 2 by 2, k minus k minus k, sorry, k minus k minus k. And we said if we have elemental stiffness matrix, then all we need to do is we need to write the displacement and force equation, which is F equals kd. And we need to find the component of F, which in case of F, in terms of the component, you have applied force and reaction force. You should be able to identify those. And then you are going to construct the displacement vector, and you need to look at since we are dealing with one directional element, you need to construct the displacement matrix such that each node has 1 degree of freedom, and you're going to look at either y-axis or the x-axis. You're going to look at the displacement at those nodes. And those are F equals KD, F part and K part is done. Then the main challenge is global stiffness matrix. And we said in order to create global stiffness matrix, you need to write down first the stiffness matrix for each element. Then you are going to determine the size of global stiffness matrix, which is size means that the number of degree of freedom times the number of nodes. In one directional beam element, we have 1 as 1 degree of freedom, and depending on how many nodes you have, you're going to multiply by that. And then you're going to create what is called expanded element stiffness matrix. Then you're going to find the location of each element in a global stiffness matrix, and you call it, for example, capital K1, capital K2, and so on. And if you sum them up, then you will end up with global stiffness matrix. Then you have global stiffness matrix, you have force vector, you have displacement vector. Put it in that equation and solve the problem. And the problem it will be based on the number of unknowns that you have, on number of equation, and when you apply the boundary condition in terms of load for fixturing, and then you will end up with simplified equation. Although you are not going to solve it by hand, you are going to use MATLAB. And that was the one directional beam element. Then we talked about truss structure. And truss structure, we said we have 2 degrees of freedom at each node. Then depending on how many nodes you have, you can find the size of global stiffness matrix, which is the number of node times 2, because each node has 2 degrees of freedom if you have truss structure. But the procedure was the same as one-dimensional element for a direct stiffness method, meaning that you're going to define the variables, you're going to find the K, you're going to find the global K, displacement vector, force vector, substitute the boundary condition, and finally use SolidWorks to solve use MATLAB to solve the problem. That was direct stiffness method for 2D. And when we look at the SolidWorks simulation to solve truss structure, we said we can use SolidWorks simulation to solve the truss structure. The only thing that we need to know is make sure that first of all you are going to create multi-body environment, and the second was as we said make sure that you can apply the fixturing and loading properly. I'm going to talk about that a little bit more today. And finally, we said when that's the approach in terms of pre-processing, post-processing, more or less is same as what you had in solid element, meaning that you have the tool in order to plot the result, probe the result, you can create the animation, you can find the forces in beam, the reaction forces, all those things that you need to identify. And also we said in terms of SolidWorks simulation, we are going to consider 3D structure as well, although we didn't cover the 3D truss structure using direct stiffness method because of the time. The procedure is same as 2D, but it takes lots of time to write the code. And but we just said, we are not going to do that. But in terms of SolidWorks simulation, we said you can create a 3D model of truss, 3D truss, and use SolidWorks simulation to find the stress, displacement, reaction force, and force member, and so on. That's just the overview from what we covered, and that would be something that you have in your midterm exam. That is subject covered. In terms of software, you will have SolidWorks and MATLAB. You have the exam is open book, and you have access to your textbook. Then you can use your textbook during the exam. My assumption is everybody has SolidWorks and MATLAB. If you don't have, then you have to use apps. What is that? Apps Anywhere. In terms of what is the content of exam, we have conceptual question and math-based problem. When I say math-based problem, let's make that one clear. That is direct stiffness method. All right. That math-based problem is direct stiffness method, and it's clear. I'm going to give you a question and ask you to solve that one and use MATLAB to solve. And in terms of conceptual question, for example, I'm going to add just one example. What kinds of error we have in SolidWorks, in FEA, or what is the convergence test, and those kinds of questions. However, I'm going to sample question will be posted. I'm going to post a couple of sample questions, at least when we say you see conceptual question, what does it mean exactly? But the objective here is I want to make sure that you understand the FEA from a concept perspective. What is FEA? What kinds of issue we have? Those material that we covered, like singularity, like errors, and so on. And that would be 25 marks. Don't forget, the combination of both would be 25 marks out of 40 marks that you have for midterm exam. And finally, we have a question, which is SolidWorks simulation itself. You don't have to do for those questions. You don't have to do direct stiffness method. You are going to do simulation and find some parameters. That is just an overview from midterm exam, quick overview. Get back to the chat room and see if you have any question. Please feel free and ask any question that you have related to the midterm exam. Are we doing a review class? One question from one student is, are we doing a review class? This is the review. What else do we need to do? Another lecture? Some of us have to be on campus right before that. Is there flexibility with the start time? That's a tricky one. Carl, why do you have to be in the campus at that time? Do you have any lab? We have ELEX lab. Can you take the exam, bring your laptop and take the exam when you are at BCIT, or how long does it take to? When is the lab is over? We do have an hour after. Okay, good. All right. My worry here is, my worry here is, I'm not sure what you guys have right after my lecture on Monday. Can anybody say, because we have 4 sets, it's a little bit chaos if I want to look at your schedule. Oh, you have management lecture, yeah? Management lecture is 1 hour or 2 hours? One hour, okay. And as far as I remember, Henry is teaching that course. Am I right? Good. All right. Then don't change the time. It seems that we have 1 hour after ELEX lab. Most probably you should be able to catch up. And one of the students said the library is open for a student now. Then you can maybe book the room, or you can go to the library, for example, or go home. I don't know where is your home, but that is one option. And that's not the issue for all the students. Maybe a couple of the students, they have that problem. Management will have the midterm on the 26th, I thought. Okay. All right. Okay, then I think the November 2nd is the good time. At the time is good one. What I'm going to do, I'm going to talk to Henry and see if it's possible to some sort of coordination. I don't know what is coordination, but I'm going to start. Other than that, it seems that we are okay. Any question about the content of exam? Timing, it seems that we are okay. Let's go case by case. My understanding is 2:30 is good to start for all the students. Even those students need extra time, they can start at the same time. Because you have 1 hour lab with Henry. I'm going to talk to Henry. I think I should be fine. Okay, yeah, thank you. All right. Any other question regarding the content of the midterm exam? Will we need to hand in DSM in MATLAB? Good question. The question is, do we have to hand in MATLAB file? Answer to that question clearly is no. What you need to do is, remember, I think I mentioned last time, and you practiced during the lab last week. And we're going to practice this week as well. You are going to solve the MATLAB, write the code in your program, in your computer, run the code, and when you go to export as PDF file, I see the code and I see the solution. You are going to create that PDF file and upload that PDF file. I'm not going to open any MATLAB files. I want to see the documented one. This is PDF. Is it clear? Okay, good. One question here is, if we did use it to solve the math question. Yes, as I said, I think it's clear now. MATLAB file. I don't ask you to upload the MATLAB file. What you need to do is when you finish, when you run your code, everything you are happy with that, go to export to PDF. And what I see, I want to see your PDF. And what I see is your code, and I see the solution as well. It's like a paper-based exam, but you are doing everything. But at the end of the day, you are going to create PDF file. Will the format for the portion be somewhat like what we do in the lab? Exactly the same as what we do in the lab. Excel file with tables filled in. Either Excel file, or I'm thinking to ask you to scan your solution, because most probably I'm going to ask you either Excel file, or most probably that would be the case. This is the first time I'm running this one with online. I'm going to ask, write down the solution on the paper, then prepare a scanner. You need to scan your paper, same as other exam that you have. It has to be done. I'm going to ask you, scan your paper. Most probably solution, you're supposed to write the solution on the paper, scan it, and upload your PDF file. And I think most of faculty do the same. Most of your instructors do the same. Any other question? With the practice program, you suppose Can you post the instruction? You will have the submission so we can practice that. Alex, what do you mean? Oh, practice problem. It's not a practice problem. It's practice questions. It's not practice question. It's sample question. Okay, sample question for conceptual. You don't have sample for that. I'm going to give you the sample. Yeah, I'm going to let you know where is that. But most probably I'm going to put it in D12. Don't forget we have 2 weeks to the exam. Yeah. Will the meter be on or PDF file we download? Will the meter be on D2L or a PDF file we download? Guys, could you please be more clear in terms of your question? For SolidWorks file, will the instruction be given for submission? Yes, yes. It more or less the same as what you had during the lab. Nothing. I'm trying my best to don't see any surprise in terms of file management. Everything more or less should be same as what you have in lab session. Same homework assignment, same. Is the midterm gonna be done through a D2L quiz? No, no, no. What I'm going to do, thank you for clarifying that one. No, what I'm going to do, I'm going to give you the PDF file of the exam. That's it. Same as paper-based. You have the PDF file of the exam. There is no quiz. I don't want to mess up with D2L. You will be given the PDF file. Take your time, solve the problem, solution done. Upload the PDF file for MATLAB, upload the PDF file for your papers, and that's it. Same as what you have in other courses. Will we have to create any parts to run the test, or will they be given? Okay, good question. And the question Chris is asking: are you supposed to create a part, or I'm going to give you the part? For beam or truss, which is chapter 4, you are supposed to create the part because this is part of the practice, part of the learning of one-dimensional beam, and also for truss, 2D truss. 3D is also included. Then for truss structure and one directional in chapter 4, you are supposed to create because this is part of FEA. For chapter 3, chapter 2, if I ask you anything related to solid element, I'm going to give you the part. You are not supposed to create any part, but make sure that you know how to create the beam and truss. No, good question from Lewis is asking about the time. Let me talk to Henry first. I'll back. Lewis asking about the time, 2 hours for uploading, preparation, and those kinds of things. Let me first talk to Henry, and then I'll talk about that for next week. Mandip is asking, and then also because sometimes the computer stops. A good question, Mandy. Thank you. The question is, what about is it a heavy simulation? It means that it takes time and computer may crash, those kinds of things. No, I'm not going to take that risk because I know that we have different computer. It's not based the same as what we had in-person class that you are supposed to go to SW9 1920 or SW3 1920 or SW9 125. We know the computer, we know the procedure. Now we are dealing with so many different laptops that I have no idea what you guys have. I'll do my best to have the point is there, but it shouldn't be heavy processes. Any other question? Good. Then I think we are now clear in terms of your midterm exam. What I'm going to do in next 20 hours for first hour is I'm going to go through a couple of points that a student asked me, and I said I'm going to talk about them for class in our lecture time. Let me just put it here. What I have from a student, they want to they have some question about 3D sketch. I'm going to talk about the 3D sketch in SolidWorks. I'm going to show you. And there's a question about the weldment, and I have some material. It's good to know for weldment as well. There are a couple of questions, and I realize Adam sent email regarding how to add torque and force to beam element, but I'm going to demonstrate that one to make sure that that one is clear. I'm going to show you, as I mentioned, creating PDF file from MATLAB. I'm going to demonstrate that one for those who are still not clear what would be the format of deliver material during the exam for MATLAB file. I'm going to show that one as well today, demonstrate that one, at least you see what I'm asking. And Olivier sent me an email and he said that I talked to Olivier, and October 28th, there won't be, which is next week, not this week, next week, Monday, there won't be any lecture for this course because he's going to use the time for his midterm. I said, okay, we need to help each other. Hopefully Henry is going to help me as well. then next Wednesday, there won't be any lecture from in this course, but that is something that I want to confirm with you guys, that there won't be any lecture on Wednesday, not Monday. Monday we have lecture, but Wednesday. Wednesday next week, not this week, next week, 28th. All right, let's jump to SolidWorks and let me share the SolidWorks with you. And starting from 3D, where's SolidWorks? There you go. Starting from 3D sketch in SolidWorks. Let me go to File and New Part. Okay. All right, we are in the part environment. As I said, for 3D, when you want to create the 3D truss, or later on in chapter 5, we have 3D frame. You need to create 3D sketch first. Otherwise, you cannot create a 3D truss. And in order to do that, in SolidWorks, we have, if you just go to a sketch, and when you go to a sketch, here we have 3D sketch. Make sure that if you want to create a 3D truss, make sure that you are going to create 3D sketch, not the sketch, 3D sketch. If you select that one, what you see here is it says 3D. All right. And then you are in the graphics area, you are in the isometric view, which wasn't the case for 2D sketch. Now, having said that, if you look at here, a sketching environment, not all the tools that we have in 2D sketch are available for 2D sketch. For example, in 2D sketch, you can draw different types of slots. You can draw polygon. But here, as you see, limited number of those sketch entities are available for 3D sketch. This is something that you need to consider. The third thing that you need to consider is 3D sketch is a huge topic in SolidWorks. And what we're going to learn this course is just the points that, or the approach that we need for simple structure like truss structure, frame structure, steel structure. Those are the things that we need in mechanical engineering field. But if you go to CAD aspect of 3D sketch, this is completely beyond the scope of this course. For those who are interested in 3D sketch, they can take it from this point and learn more. But that is not the objective of this course. If you look at here, if you go to the 3D, go to the sketch entities, when I invoke the tool line, what's going to happen here is, you see there is it says XY. Look at this one, the pen itself. It says that you are going to draw in XY plane. Where is XY plane? I'm going to start from here, but it's going to say that whatever you do here, it's going to draw in XY plane. And XY plane here is the plane that is parallel to this XY. All right, I'm going to start, for example, I'm going to start a line from here, and then see, I'm in a XY plane, although it's 3D environment, but as long as I see that XY, it means that you are in XY planes. Let me rotate that one, you can see it. There you go. See, you're in that plane. Now, if you want to move from that plane to another plane, all you need to do is hit the tab key. Then as you see, now we are moving to YZ. YZ now is parallel to this YZ here. Then I can start from here and say, for example, I can come here, then I can go up, and so on. Then one more time, the 2D and 3D, the difference is when you are in the 3D, let me go to isometric. In 2D, you do not have choice to jump from one sketching plane to another one. In 3D, you can. All right. In terms of the concept of fully defined sketch, underdefined, same. You need to apply appropriate dimension. Make sure that your sketch is fully defined. How much is that? 50, say 100. Now your sketch is fully defined. See? Now, one more thing that I want to say, and we had that tutorial is, if I'm in a 3D sketch environment, see, alternative is I can create those points and connect them together. But how I can do that to make sure that the points are at the right location? I'm going to say, create a point, put it somewhere. And now you see the coordinate of that point are shown here. For example, now x is 0. I'm going to say x, which is in this direction. I'm going to say that one's supposed to be, where should we put it? Say 50. And y is, which is this direction. This is 100, 150. Let's put it, that one is say 400. 400. And z, which represents in this direction, let's say 75, half of that one. Now let's see what happens. I'm going to accept. Now, if I go to isometric one more time, see that point is generated at the location that I want. However, your sketch is not fully defined. Okay, your sketch is not fully defined. You can fix this point, or say I'm going to draw this line from here. This time I don't have to worry about jumping from one plane to another one. See? There you go. See, this is still 3D. But I don't have to jump from one because I created the point first. Now, having said that, the sketch is not fully defined. Let me just move, maybe, let me go to this point. X, let's go to X, say 10. Move it a little bit that way. You can see it's 3D. Z 400 is too much. Let's go. Sorry, Y 400. Let's go 200. Good. Now, as you see, the point is good. It's 3D. It seems that it's easier approach, but you have to make sure that this is fully defined. Meaning that I need to put the dimension here to make sure that a sketch is fully defined. In order to do that, if you go to a smart dimension, for example, from here to here, see, if you just hit the tab key, you can put the dimension, say, this is X. There you go. I'm going to accept it. Then I'm going to continue from here to here. Again, what I'm doing, I'm hitting the tab key. See, that's a 200. I'm going to accept that is for Y. And the last one is Z from here to there. I'm going to hit the tab key. There you go. Accept that. Now, your sketch is fully defined now, and it's easier to put the dimension this way. Both approach works. Any question about 3D sketch? You should be able to draw a 3D sketch, but as simple as I showed you, not complicated sketch. Now let's go talk about development. Go to a little back to SolidWorks. Now I'm going to quit. Okay, we can work with this one. Let's quit from here, and we are going to work with this one. It's a good one. Let's keep that for 3D sketch and add development to this one. Now this is the sketch I created. It's fully defined sketch, 3D sketch. Now I want to put development. Development are a standard shape in SolidWorks or in real life, like I-beam, square, tube, L bracket, C channel, and so on, that you can use in SolidWorks environment. Very interesting tool in 3D environment, including SolidWorks environment. And in order to simplify the design, the objective of this course really, it's not to talk about development and more in details. This is not an engineering graphic course, but it's good to understand that the application of development is huge because whenever you have chassis, frame, or still a structure, you have I-beam, C channel, you have all of those components in your design. However, you can take it from this point and learn development, but what we need in this course is the application in terms of truss and beam. One approach, as I said, go with extrude. Another approach is use weldment. In order to apply weldment, you need to have first a 2D or 3D sketch, depending on your problem. In this case, I have a 2D 3D sketch. I'm going to say I want to create a weldment, and I want to create a structural member. And when I say structural member, it says, okay, what is standard? I'm going to say, in this case, for example, let's go with ISO, millimeter one. And I'm going to say, I want to have, let's say, doesn't matter which one, let's go with a square tube is more clear what's happening. All right. And the size, I'm going to say the size is 2 millimeter by 2 millimeter. Now, as you see here, there is a grouping here. All right. There is a grouping here, and you are not supposed to create groups. Let's see what does it mean exactly. And what I'm going to do, let me just, in order to cover the concept group as well, let me back here. I'm going to add a couple of more lines here. Let me just hide the dimension. You don't want to see the dimension. There you go. And then I'm going to say, let's connect this line from here to there, and from here to there. And what else? Where is that? Fine now. Somehow it's not coincident. Oops. No good. All right. Assume that this is the truss. I'm going to add one more. What I did, I just put more members here because I want to talk about the groups. Now, I'm going to quit from a sketching environment, back again to weldment and a structure member. And the setup is there. Now, this is what I'm saying when I said do not create the group. What I'm going to do, I'm going to say, okay, starting from here, I want to have, there you go. It's too much, yeah, in terms of size. Yeah, it's too big. Too big. What should I do? But it's good. It's too big. I don't like it this way. Let's see. The reason is, let's keep that one. Let's back to a sketch and make those. I'm going to change those dimensions. There you go. Let's go this one, say instead of 80, I'm gonna have 500. Huge. It's crazy. And this one, instead of 100, say I'm gonna have 400. And say this one, and let's say 300. 1000. Much better, yeah. That one is good. 300. This one, say 200 is supposed to be. Which one is that? That point is, oh, that height of that one. Okay. Let's change this 10 to 200. I think they're good now. And maybe this 75 to, I don't know, 300. Yeah, I think we are good now. Let's see that back here. What I did, I changed the dimension to make more sense because the size of the development is huge. All right, so let's go to isometric. There you go. Now, what I'm going to do, I'm going to go again to a structure member, and I'm going to say this one. Yeah, makes sense. This is more. Now, see, I'm going to continue. I'm going to continue. See, I'm going to continue as much as I can. See, as much as I can. It means that I can go here, go there, and now I cannot select this one. It means that you are done. Do not, you can create a new group. Please do not do that for trust analysis. Do not create, and make sure that corner treatment is not there. Those are the tools that we need for CAD perspective. For FEA, do not create a new group. Although I know some of those members are a sketch member, I need to add member to those. But when I finish with the loop, which is a start to the end, then I'm going to say, do not apply corner treatment, and I'm going to accept. Now, this is what happened. You see, there is no corner treatment here. There is no corner treatment here. See, there is no corner treatment at that corner as well, because I didn't use the loop. I'm going to continue structural members. And this time, I'm going to say, again, without touching this area, I'm going to say, what about this member and this member? Make sure that corner treatment is not there. Which is not, I'm going to accept it. And finally, I'm going to say a structural member from here. Let's see if I can select that. Yes. And no new group. Don't touch this area, and make sure that apply corner treatment is there. Now let me zoom in here. You can see what's happening. See, and all of the reason is from FEA perspective. If you say corner treatment, then here you have some sort of treatment, maybe, I don't know, some sort of miter angle and so on. You don't want to deal with those because you need to, in your direct stiffness method, or sorry, in SolidWorks FEA, the stiffness method is based on the actual length. But if you apply corner treatment here, then you are losing that actual length. And as you see, it's a very straightforward, very interesting approach in SolidWorks simulation. However, when you go to, for example, here, I'm going to create a simulation from this, just a couple of steps. I'm going to say create a new study. This is a 3D. And everything is okay. Yes, static. See, this is what I want to talk about. It's going to create a cut list. We don't care about cut list. Cut list is for CAD. Okay, but if you expand that one, see, all of those members are there. What I typically do, I go here and say, you know what, I don't want to have cut. Then you have all the beams, you can see them. For chapter 4, we are supposed to have truss structure. Then what's happening here, you have beam. As you see, those are beam. You need to convert those to truss. I'm going to select all. I'm going to right click, edit definition. And here I'm going to say those are truss. Be careful. It has to be done. I'm going to accept. Now it's changed. Now you have trust. And the rest is, I think, is straightforward. Let's back to the chat room. And this question was, is it possible to post the lab 6 hand in on D12 so we can upload our files if we are finished? I'm not sure what they're talking about. If it's something related to homework assignment, please talk to Adam. For lab 6, I created groups in Will. Oh, I see. No, redo it. If you created the group, redo it and upload. And Adam is going to, and send email to Adam, not to me, please. Adam is taking care of this. If there is no question about grouping, okay. I just found out that our machine design midterm is actually on November 2nd. No, it's not. Your machine design midterm is 28. This is what I was told. All right, the next is, we talked about weldment, we talked about, okay, now let's talk about the torque. Okay, then let me talk, okay, it seems that there is a machine design, Olivier reschedule all the two. Okay, let me talk to Olivier. Let's keep that November 2nd. If he rescheduled the exam, then I need to talk to him, because that's the only chance that I have. I can take one, and then I don't have option now to remove it to November, anytime before or after that. The reason is, if you move it to after, they're really close to final exam. If you want to move it sooner, then what's going to happen is you don't have enough time. We need to. I'm going to talk to Olivier today. Don't worry about it. But let me talk about it to Olivier. One more thing that I want to talk here is, I want to talk about. Please start talking about the exam. Just focus on here. I'll talk to Olivier. One more thing is, there you go. What about if I want to apply torque? That was question some students have. I want to apply torque, for example, here. Although in truss structure, you are not, let me just open a new one, because we are not applying torque to the truss structure. Yeah, because the 2 force member. Let's go here. And I'm going to say front plane. We can draw a sketch here. A sketch. There you go. One meter. And say this one is 1 meter too, or half a meter. All right. This one is not there. There you go. Now let's quit from this one. Let's add the weldment. Cut it from isometric view. Everything is okay here. I'm going to add this. And I'm going to add that one. I'm going to accept. Now, if I go to FEA and create a new study, say yes. Now, I want to apply, let me just put this one in terms of display mode to wireframe. You can see what's happening here. I want to apply torque to this. No, let's see what is the torque. If you go to force, you can apply to the joint. I'm going to apply to this joint. All right. And for example, I want to apply bending moment to this one. I'm going to say, with respect to this plane, which is front plane, all right, I'm going to apply torque. This is perpendicular to this plane, yeah? Say I want to apply, I don't know, 20. And now, as you see, there is a pin here. And that pin is based on right-hand rule, meaning that This is your right hand. Your thumb should be along that pin. Let me exaggerate the size a bit. Wow, such a pin, yeah. This is 0.5 meter, and this pin I think is 30 centimeters, something like that. Now, see what's happening here is if you want to see the direction of this torque, put your thumb, right hand, put your thumb along that, hold your thumb along that pin, and your finger shows the direction of torque. Then if you look at this one from this view, you are going to apply counterclockwise torque, okay? Because this is the direction of your thumb, and that direction, that pin represents your finger, shows the direction of torque. Then the torque that you're going to apply here, if you look at it from, say, front view, if you look at it from front view, from this view, that is going to create counterclockwise. Any question? Those are the materials that I wanted to cover in terms of some question that the student have in terms of SolidWorks and SolidWorks simulation. One student asking, is there any reason why I cannot run the study after changing from beam to truss? You should be able, if everything is okay, you should be able to do that. Unless there is a specific issue, then talk to me, send me an email later on. All right, let's have 10 minutes break. We are going to start at 3:26, 3:36. 3:36, we are going to start the second part of lecture, which is the new material.